Okay, let's consider this problem. The absolute value of x of a real number, x is defined as this. So when x is positive or 0, the absolute value of x is just x. And when x is negative, then the absolute value of x is negative x. So since x is negative in this case, negative x becomes positive. So that means the absolute value of x is always positive or 0. Okay, so that's an important property of the absolute value of a real number, or any number actually. So what we want to do is the following. So prove these two things. For any real number x, x is between negative absolute value of x and positive absolute value of x. And second, for any positive number a, for any x, real number, if x is between negative a and a, then the absolute value of x is less than or equal to a. Okay, let's prove this. But first, I will show a wrong proof. Okay, I've seen many students do this. In summary, examples cannot replace proofs. Okay, so we want to show this thing for any real number x. So here's the wrong proof. Okay, part 1, proof. It's wrong. Let x be equal to 2. Then absolute value of x is 2. Therefore, negative absolute value of x is negative 2. Therefore, negative 2 is less than or equal to 2, which is less than or equal to 2, which is true. Therefore, we have this. Negative absolute value of x is less than or equal to x, which is less than or equal to the absolute value of x. And therefore, we are done. This is wrong, of course. So what's wrong with this? We assumed x is equal to 2. So what about when x is equal to 3, or negative 1, or negative 1.035, or whatever? What about when x is pi, or e, or pi to the power of square root of 2, and so on? As you know, there are uncountably many real numbers. We cannot prove like this. We have to do this infinitely many times, which is impossible. So we have to do, what we have to do is to prove this for any x. So only using the general properties of any real number to prove this. Okay, so here's the correct proof. According to this definition, we have to separate two cases: when x is positive or 0, or when x is negative. So, any real number can be either positive or negative or 0. So we consider these two cases. If x is, okay, so here's the correct proof. Okay, correct. When x is non-negative, that is positive or 0, then absolute value of x is equal to x, according to the definition. Okay, therefore, which is actually greater than or equal to 0. So therefore, negative x, absolute value of x is less than or equal to 0. But 0 is less than or equal to x, which is equal to the absolute value of x. Therefore, this inequality, x, equal is included in less than or equal, so we can say this. Because of this, we have this. Okay, so this is when x is non-negative. And if x is negative, then we have absolute value of x is equal to negative x, which is positive, right? Because x is negative, negative x is positive. So, therefore, negative x is less than 0, which is less than negative x, which is equal to the absolute value of x. So we have this, and so if we multiply everything by -1, we have this. The absolute value of x is greater than 0, which is greater than x itself, which is equal to negative absolute value of x. Therefore, we have this greater than or equal x greater than equal negative x. Of course, we can swap right hand side and left hand side to have this. So in either case, so this completes all the possibilities. X can be either 0 or positive, or x is negative. So this completes all possibilities. So in either case, we have this and this. Therefore, in either case, we have the desired inequality. And we are done. So here we didn't mention any specific number. So x can be any real number. So this holds true for any real number. So that's why this proof is correct. Next, let's try part 2. Suppose a is any positive number, and then for any real number x, if this is true, x is between negative a and a, then the absolute value of x is less than or equal to a. Okay, so a positive is given. So suppose x is between negative a is less than or equal to x, which is less than or equal to a. So suppose this is true. Then we want to show that the absolute value of x is less than or equal to a. So we want to show this, okay? So what can we do this? About this? Okay, again, if x is positive or 0, then we have the absolute value of x is equal to x. So in this case, therefore, we can just replace x with the absolute value of x. So we have this. So this part is true. Okay. Then if x is negative, then we have the absolute value of x equal to negative x. So therefore, we can replace x with negative absolute value of x. Therefore, we have negative absolute value of x less than or equal to a. So if we multiply everything with -1, we have a greater than or equal to the absolute value of x. And this is greater than or equal to negative a. So for this part, we have the same thing here and here. So in either case, we have this. So the absolute value of x is less than or equal to a, and we are done. Again, in this proof, we do not use any specific real numbers like x equal to 2 or 1 or 3 or whatever, but we just use a general property of a real number, any real numbers, right? So it can be positive or 0 or negative. So that's all we need here and here. Well, a is given as positive number, so it's just positive. It can be 1 or 2 or whatever, 0.00001 or whatever. for any real numbers a and x and a being positive, if this is true, then this is true. So that's the beauty of this general proof. So in summary, if you want to prove some general properties of real numbers, you can only rely on the general properties of real numbers. In this case, it's this, just positive or negative or zero. And we're done.